We're going to take a minute, make sure everybody gets in the meeting before we all start yakking. So if you're there, hang in.
This is a good time to go get a couple fresh beers so you have them lined up for the full length of this 6-hour talk.
It's going to take more than 2 beers. Oh, there's my dogs. Hopefully they will be quiet. We're going to wait another minute, then we will start the program.
All right, guys, this is Kevin. We're at 9 people are logged in now. We're at 35 signed up. We'll see how well that goes, but yep, 10 now. So people are joining in. We'll give them a couple minutes and then fire it up. I'll let you know when we hit about 20 or so. Okay.
Okay. Then I'm gonna go get that beer.
For the attendees who are already logged in, we do have the chat function is closed because of some issues we've had in the past. So basically we'll be using a Q&A format. We'll be seeing the questions that come in. They won't go to the general chat until I approve the question. So feel free to chat, but only legitimate questions will get approved and pushed into the queue. Okay, guys, we're at 13 attendees now. We'll just give it another minute or so, and then people can join in as we go.
I've been late for meetings before.
I've been late for talks I've been supposed to give in radio shows. So I excuse pretty much any tardiness.
Do you take attendance in your classes?
Well, I try not to because I know what it's like, you know. A lot of times if I can get there, I'm happy about it, especially now. I've got 2 kids and a dog and all sorts of craziness. So, you know, I feel like a 5 or 10 minute buffer is not ideal, but it's acceptable. So, and there's nothing in the beginning of the talk anyway. Nobody will miss anything if they show up late.
Hopefully it builds though.
Yeah. Yeah, it builds their crescendo right at the end.
Okay. Well, I think we should get started, Kevin. Since he didn't respond, we will start. I'm Mike Harrington. I am the chairman of the Newport chapter of Surfrider Foundation. This is our October meeting on Zoom. A couple of calendar items that are coming up. We'll take care of some business and then we'll start the program. If you're here for the Shark Talk, you're in the right place. If you're not here for the Shark Talk, stick around. It's going to be good anyway. On Monday of next week, there is another webinar on offshore wind energy. There'll be a panel discussion. You can sign up on Eventbrite. It'll be presented on Zoom. If you want to learn more about offshore wind energy, there'll be an expert panel of local officials, state officials, and industry people. And this is something that is coming down the pike and something we all need to know as much about as we possibly can. So you can go to the Oregon Surfrider webpage and scroll down to the offshore wind energy article, and there's a link to sign up on Eventbrite. It's a Monday, October 19th from 5:30 to 7. And then the following Saturday, the Newport chapter is going to have a highway cleanup. The beaches around here in Newport actually look pretty good, but all of the roadways are completely trashed because there are so many people traveling now. So we'll have a highway cleanup. there'll be information about that on the Newport Surfrider Facebook page. It will be from 2 to 4 in the afternoon. And the meeting point is Moolock Beach parking lot, which is north of Newport. And we take care of a section of highway. It's about 5 miles long, basically between Newport and Otter Rock. And then I want to encourage everybody tonight, if you haven't donated to the Echo Mountain Fire Relief Fund, to go back to the Eventbrite sign-up page and donate money. This is a little bit outside of our regular mission, except that we're part of a community and these fire tragedies happened in our community. And if you're not from the coast, if you're from the valley, there are similar organizations over there that need help to get fire victims back to normal. We're raising money for the Echo Mountain Fire Relief Fund. They're a 501c3 nonprofit, so it's a tax-deductible donation. This is a group, a real grassroots group of people in Lincoln City that got together and are raising money for uninsured and underinsured victims of the fire and people that are left out from regular relief efforts. So you can donate in 2 ways. You can go to the Eventbrite page and donate through Eventbrite. All of the money will go to Echo Mountain Relief. There were some fees involved when we first set this up, but the Newport chapter is going to take care of those fees. Any money you donate goes to Echo Mountain Relief, or you can send a check to Echo Mountain Fire Relief at the First Interstate Bank in Lincoln City. And like I said, if that isn't immediate to you, but you live in Salem or you live in Portland, there are similar efforts going on in other places. And there are other organizations that are helping fire victims. The Red Cross, the United Way, St. Vincent de Paul. There are a lot of good people doing a lot of good things. They need our support. We will move on to the program we have tonight. We have Dr. Taylor Chapple is an associate professor at the Coastal Oregon Marine Experiment Station. His research focuses primarily on large marine predators, most notably sharks. I won't try to explain what he's going to talk about because he's going to do that. If you have questions, put them in the chat and he will do that at the end of his presentation. And myself, as someone who regularly gets in the Pacific Ocean, I'm all for understanding the habits of the creatures that I'm sharing the water with. And so I'm looking forward to this presentation. I will turn it over to Taylor.
Great, thanks a lot, Mike, and appreciate being here and appreciate everybody that's here. I guess I want to echo Mike's sentiments and just remind everybody, if you can, to help donate. There's a lot of folks that are definitely in a different situation now than they were a few weeks ago before the fire. So I think anything that we can all do to help them is part of what we do as a community. So with that, I guess I'll get started. I'm going to start sharing my screen. And so what I'm here to talk about tonight is about sharks and a lot about the sharks that are off our coast. And so I do work with sharks all over the planet, big sharks, small sharks, predatory sharks, planktivorous sharks. But what I want to talk about is the ones that we have next door. So these sharks that are out our back door, that when we're out surfing or out swimming or diving or whatever we're doing, these are sharks that we might interact with. And my real goal as a scientist is to change our perception, is to change that idea of fear and apprehension of these animals to more of a respect and appreciation for what they bring to our marine ecosystem. So I'm sure we're all very excited to go to the beach and see a beach that's clean and a beach that smells good and smells like the ocean. And white sharks and other species of sharks are what we call apex predators. So they're on the top and they're helping maintain those systems and keeping them healthy. The same way that The same way that we work to maintain the beaches by doing cleanups and as the road cleanup that Mike was talking about, these animals are doing a really big part to keep these oceans healthy for all of us to use. And so part of my goal is to talk about the role that these animals take and to understand a little bit better about how that whole system works and what these sharks are doing. So this is what most people think of when they hear the word shark or someone starts talking about sharks. And it's the idea that there's these mindless predators that are out there that are just there to eat everything that they see. They're these giant toothy animals that are basically stalking the beaches waiting for us to step in. And a lot of that, stemmed from this quintessential 1970s film Jaws. I'm sure you all recognize that photo, and that really got into the psyche of not just the American people but the global population, about that the sharks were this mindless predator that were really just out there to eat us. But the truth is that sharks are not that dangerous in the grand scheme of things, and so you're much more likely to die from a selfie than you are to be attacked by a shark. But the selfies and selfie sticks don't have that same sort of fear factor that come into play when someone mentions them, as you would if someone said shark. And the truth is that the way that we interact with sharks is more likely going to be deleterious to these animals than to us. And so these are a few ways that we're more likely to interact with sharks in our day-to-day life. And so there's a picture of a boat on the top, and that's actually in the Southeast US, a shark fishing boat that I was out taking research samples for, and that still goes on. And then these different sort of beauty products and shark cartilage products that are used as a sort of I think it's more of a placebo, but supposed to have some medicinal values. And then on the bottom right, which many of you are probably familiar with, it is shark fin soup, which is really the driver of much of the shark declines globally, because the value of this soup in many of the Asian countries. So what I want to do is maybe get back to the reality of it. And so go away from the hype, this Hollywood hype about sharks, and start talking about more of the facts, the things we actually know about these animals. Because it turns out that there's a lot of things we don't know yet. And there are some things that we're very sure about. And so what I can do is present some of those and talk about the type of research that I do and my community and my colleagues do to understand these animals. And so what I'm going to start with here is talking about white sharks. I guess they're more commonly known as great white sharks, but we've, as a scientific community, have tried to step that back a little bit and get rid of some of the hype. And so you'll just hear me talk about them as white sharks and not great white sharks, but it's the same species. And after that, I'll talk about some more of the other species that are really important to our coastal marine ecosystems throughout the Pacific Northwest. And so for white sharks, there's basically 6 genetically distinct populations. And so each of these circles that I've made on the map show a different population. And so what being genetically distinct means is that these animals have not overlapped, they've not interbred in tens or hundreds of thousands of years. So they're completely distinct populations. So if we killed all of the animals off that were in the Northeast United States, there isn't another group of animals that would seed that or that would come in. That population would be gone forever. So each of these circles is distinct. So you have, starting from left to right, is the Northeast US or the Northwest Atlantic, however you want to call it. The Mediterranean, which is in blue because we don't know very much about that population at all. South Africa, Australia, New Zealand. Then a population in the Western North Pacific, so basically off Japan, which again, we don't know that much about. And then the Northeast Pacific, which is the population of sharks that I'll mostly be talking about tonight, and the population of sharks, of white sharks that we're all going to interact with in our coastal waters. So white sharks, when they're born, are somewhere between 1.2 and 1.5 meters. So that's about 4 feet long. They're live born. And so there's no parental care. They're free swimming from the moment that they're born. Their litter size is somewhere between 3 and 14 animals. And we think that the average is probably about 8 to 10, but that may vary based on the size and the health of the mother. So We know that in fish like rockfish that the larger, older individuals have bigger and more numerous offspring. So that may be the case with sharks, with white sharks, but we don't know that much yet. They're regional endotherms, and this is a key. This is like the coolest part about white sharks, is because their regional endotherms means that they can heat different parts of their body. So if you go out in the ocean and you catch a salmon or you catch a rockfish, it's going to be cold to the touch. But a white shark is able to maintain a body temperature that's higher than ambient. So like us, that we keep our bodies at 98.6 degrees, the white sharks can keep their elevated body temperature. And that allows them to be really dynamic in really cold water. So you think about a snake. A snake, when it gets cold, it gets really lethargic, can't move very fast. But once it gets warm, then it can be much more dynamic. And so sharks are the same way. So once the white shark is, because it's warm, it allows it to be really dynamic in really cold water. And when they're feeding on things like marine mammals that also are warm-bodied, it really gives them an ability to track and catch those marine mammals. So they also go through this, what we call an ontogenetic shift. And so basically when they're born, they're at that like 4 feet size. When they get up to somewhere between 7 and 9 feet, they transition. And so when they're born, they're eating squid, other fish and sharks. But when they get to 7 to 9 feet, they get big enough that they have what we call thermal inertia. So they're big enough to basically move into colder water, and they switch their diet. And so they're starting to eat marine mammals. And so when they're young, they're in the Southern California Bight, so around LA, San Diego, Santa Barbara area in that warm water. And then when they hit that ontogenetic shift, that's when they have their body basically has enough mass that they can stay warm in really cold water. So that's when they start moving up our coast, and they start making their way up to where we are. And that's when they transition into feeding on marine mammals. And one sort of interesting aside about this is that climate change, as we all are very well aware, has really changed the temperature of the waters around us. And so we've seen these big warm water blobs or plumes that have been coming north. And so that's actually starting to shift the available habitat for those young sharks. Instead of being in Santa Barbara, now they're in Monterey because the water is warmed all the way up to Monterey. So that ontogenetic shift, although it still happens, is actually, it's transitioning a little bit, that the animals are no longer in Southern California, but in Central California as well. So that has implications, which I'll talk about later, for how we see those animals distribute up to where we are up in the Northwest. So they have a gestation, which is between 12 and 18 months, and females probably take a year off in between. So that means that a female at most is having offspring every 3 years. And we think it may actually be longer than that. It may be 5, 6, 7 years between pregnancies. Populations, I'll talk a little bit about this in a minute, but global populations at each of these different sites is either in the hundreds or low thousands for each of these individual populations, which is a small number, but we're still working on whether those are healthy populations or if that's something that's actually at risk. Most of these estimates are just point estimates. We don't have trend lines of how the populations are doing. The maximum age for a white shark is about 70 years, and that's just a recent finding that we thought about 10 years ago, we thought that they lived to be about 35, and we've just reassessed that. So, again, new information is coming in all the time. And they do these really cool large-scale migrations, and that's a lot of what I'll talk about today. And so if you look at this, these different things that I've written up here, you see question marks next to some of them. And that's because these are characteristics that we think we know, but we're not necessarily positive. We've inferred them from other places. And so it just gives a sense of some of the fundamental information about these animals, like how many offspring they have and how often, that we still don't even know. And we don't necessarily know where reproduction and things like that are happening, but I'll talk about that in a minute. So stepping back, one of the first questions that folks often ask me, and especially when we're all surfers and getting in the water, is, well, what's going on with shark attacks? What is my risk? I'm worried about getting in the water. I see all this hype on television. Is are shark attacks going up? Is it increasing? And the truth is, so if we look at this statistic, this is on the bottom is the year, and then on the left side there is the number of attacks. And if you just sort of follow the trend from left to right, you can see that the number of attacks is increasing. The blue is the US, and then the red is other countries as well. And you can see that generally over time, that the number of attacks is increasing. So on face value, you say, all right, well, global attacks are increasing. But there's also other things to consider when we think about the number of attacks that are happening in the water. Things like social media, the number of people in the water, the ability for people to communicate an attack if it happens. So you being able to call into EMS or something like that very quickly. So all of those may have an effect on the number of shark attacks that we see. So some of my colleagues and I wanted to understand the rates of shark attacks and to see if we could figure out some of the drivers. What was really driving that? Was it really the number of sharks? Were the sharks just getting a taste for humans, or was there something else happening? So we went to California, where there's good statistics on shark attacks and good statistics on beach users. So surfers, abalone divers, swimmers, and scuba divers. And so we looked at these different metrics, and we wanted to see how the numbers of people in those beach use categories changed and how the number of attacks changed. So if we look at California, these are just the sheer numbers of attacks. So each of those green dots shows how many attacks happened in that year. So this is from 1950 to 2013, and then that's the number of attacks on the left side. So you can see there's a little dotted line in there if you look real close, and so you can see it's sort of creeping up. So there is an increasing attack rate or number of attacks in California. But at that same time, the millions of people in California is also growing quite rapidly. So what we did is we went through to these 4 different beach use activities. So you have on the right side, there's a little caricature of each of the activities. So there's scuba diving, surfing, swimming, and then abalone diving. And if you look at the figures on the left, that is the number of people in each of those activities from 1950, or I guess some of them are from 1970, but from the early 1950s to 70s until now. So you can see all of those activities have increased rapidly, especially surfing. It's basically exponential growth in the surfing population. So when we match that up with the number of attacks for those different groups, each of those beach user groups, what we see is that the rate is actually dropped. So this is just the number of attacks on surfers. And we took into account the number of surfers in the water. And if you just sort of follow those lines down, don't worry about the colors, but the idea is that you see a significant drop in the general trend of all of those lines. And so what that's saying is basically from 1950 until 2013, the probability of being attacked has dropped precipitously because there's so many new people in the water that the attack rate hasn't kept up. And that's the same thing for all of these different beach user groups. Take-home message is, since 1950, your probability of being attacked by a shark has dropped by over 90%. And so while the numbers themselves, the actual numbers have gone up very slightly, your actual risk has gone down precipitously over that same period of time. So this is just one of these sort of analyses that I like to share with people who are thinking about getting in the water, is that it's a lot safer to get in the water now than it was 50 years ago. So now we'll get into some more of the research, some of the field research I've been doing. And so these are the 2 of the study systems that I'll talk about today. One is California, and the 3 spots that I've worked the majority of is in Central California in the San Francisco Bay Area. And that's Tomales Point, just north of San Francisco, the Farallon Islands, about 25 miles west, and then Año Nuevo, which is about 25 miles north of Santa Cruz. And then the other spot that I'll talk a little bit about is some work I've been doing in Gansbaai, South Africa. So it's basically between Cape Town and the very southern tip of Africa. And there's a spot called Shark Alley between Dire Iron and Giza Rock. If you've ever watched Shark Week, it's a pretty common spot for folks to go and shoot those shows. It's a well-known shark spot there. And so the way that we find these animals is that we go to places that we know that they aggregate. And so there's historical records of sightings or attacks at these different locations. So we go there and we use a visual stimulus, which is a decoy. And so this is basically indoor-outdoor carpet that looks like a seal. And we set it on the water because these animals we think are there to hunt. And so we're basically exploiting their visual hunting strategy by putting this decoy at the surface to try to coax them up. This is what the decoy looks like a few weeks later once you successfully coax the animals up. So they come up and they'll investigate it, they'll bite it, they'll sniff it, they'll swim around it. We ended up going through a lot of zip ties in the season because the sharks, they're very visual hunters. So if you put something out that looks like their prey, there's a good chance that you'll get them attracted to it. And again, these are aggregation sites that we know of. We also put in a small piece of marine mammal blubber. And so this isn't a big chumming escapade like you are probably familiar with on TV. This is a really localized scent. So it's about less than 5 pounds of whale or sea lion or seal. And the idea behind that isn't to bring sharks in from all over the place. It's to, once a shark comes up to see that decoy, it gets into that little smell plume that's around the boat. And that's enough to keep it interested so that we can do some of the science that we need to get. Get some of the data that we need to get. So the shark comes up, sees the decoy, looks at it, smells the smell, and then circles the boat a few times. During that time, we do photos. We'll do photo IDs, which I'll talk about in a second. And then we'll do external tagging. And so this is how the process works. So we've got the one guy standing up. He's got the decoy out basically on a rod and reel. He's bringing it towards the boat. One of my colleagues has a white pole there that's got a camera on the bottom that will take photos with underwater or on the surface. And then I'm on the back of the boat trying to apply one of the tags. So one of the first questions that we had when I started this project in 2004, 2005 was, well, how many sharks are we talking about? Is this a population that's in the tens of thousands, hundreds of thousands, or in the single digits? And so in order to understand the population, we were able to utilize the unique characteristics of these animals. So it turns out that their dorsal fins are basically like a fingerprint. So each animal has a unique dorsal fin that's basically retained over its entire life once it hits that ontogenetic shift anyway. So from when it's about 7 to 9 feet long up until it gets to 15, 16, 20 feet long, those dorsal fins don't really change. And so some people like to think of them as a fingerprint for these animals. So if you look at these two photos, you can see the peaks and valleys on that trailing edge, the back edge of that fin. Even though these photos were taken 3 years apart, that fin has not changed at all over that period of time. So basically what I was able to do is every year go out, photograph the sharks, and by doing that over a series of years, was able to estimate the abundance of sharks off of Central California. And it turns out that there's only about 220 of these white sharks off of Central California. And that Central California group makes up a pretty good portion of the entire West Coast population. So for us, it was a bit of a shocker that the populations were that low. But as I said before, we're still not sure whether that's a healthy number or whether that's a number that we should be concerned about. It's not uncommon for apex predators to be in low numbers. And there's a lot of protections in place since the 90s for white sharks off of the West Coast. So we're hoping to find in the next year or two some good trend information about where this population is actually trending, if it's going up or this is a healthy population, so it's staying stable. So that gave us a little bit about the abundance, the number of these animals, but we wanted to start to understand the movements and the behaviors. And historically, our understanding of white sharks and a lot of marine animals came from these brief moments of interactions at the surface. And so this is probably something if you've ever watched a show on sharks, something that looks familiar, where researchers coax an animal up to the surface and they take a photo or they take a video and they say, all right, we've got it nailed down. We know what these animals are doing. We knew everything we need to know about white sharks. And that's kind of crazy to think that we've got this 30-second interaction, this little red line on this time scale that I put up here, and we can say what it's doing the rest of its life and the rest of its day from that brief moment. So, I mean, it's sort of like, and I guess I've said this before to some people, but if I was to catch you in the morning when you're at the coffee shop getting a cup of coffee, and I took some notes and took some photographs of you doing that, and then I went home and said, hey, I can tell exactly what you did all day, what you eat, what you drink from those few minutes that you were in the coffee shop. And using that analogy, it doesn't make sense, right? It doesn't translate to your full day about what you did those few minutes when you're in the coffee shop. So it's the same thing with these animals. The only way that we can really understand what they're doing is by going on board with them, being underwater when they're underwater, and going where they go. And so unfortunately, we can't physically do that ourselves, but we have some really smart people out there that have devised some ways to do that with electronic tagging. And so the first type of tagging that I'll talk about is called acoustic tagging. And I guess I'll go back to this. And so the way that acoustic tagging works is that we put these small tags on the back of a white shark, and it travels with the sharks for 2, 3, or 4, or 5 years. And every time in every 60 seconds, that tag will emit an acoustic ping that says, I'm shark 64, I'm shark 64. And the problem with being in the water is that you can't just put a GPS on a shark. You can't, the GPS signal can't get through that air and water interface. So we have to use something different. So these acoustic tags, what they do is the same way a submarine sends out an acoustic signal, the acoustic tags send out an acoustic signal as well. And so if we place receivers up and down the coast, or places we expect the sharks to be, anytime shark 64 swims within about 800 meters of that receiver, it detects it and then transmits that information to us. And so at that moment, I know that shark 64 is at the Fairlawns and it was there 30 seconds ago. And so by putting these tags on the sharks, we can get an idea of when they are at these locations we expect them to be. So these are the data that you get from the acoustic tags. And so don't worry about the colors, but what I want you to focus on is on the bottom axis. So the x-axis is years, years and months. And on the y there is the detections per day. So if you just glance at it, you can see that basically from August through March, the white sharks are present. They peak somewhere in October and November, then they go away. There's no sharks detected from about April, from about April to August, and then they come back the next year, and then they come back the next year. So this is a good way for us to look at these cyclical cycles of the sharks being along the coast. So we've got receivers at the Fairlawns, we have receivers at Smallest Point, and a few places up and down the coast. So it showed us that where those receivers are, the sharks show up every year very predictably to those locations. The problem with these acoustic tags is that they don't give us any information about when the shark isn't there. So those big breaks between April and August, you can see that we don't know where the sharks are. These acoustic tags don't give us any information about where those sharks are when they're not at these acoustic receivers. So we basically had to come up with a different way in order to estimate or to determine where those animals were. And so in walks the satellite tag. And the satellite tag is a little bit different because the satellite tag allows us to actually to record where the animal is. It's basically like an onboard computer. And so you put this tag in the back of the shark the same way we do with an acoustic tag. It's basically a pole spear. The shark swims around. We put it in like a little dart into its back. But the satellite tag is a little bit different, that it archives the information and basically will record the depth and the temperature of the water, the depth that the shark is in, and then the light level. And then we use a fancy algorithm to turn light level into location, the same way that an old mariner used to convert his local noon to noon at Greenwich Mean, and then figure out where he was. So it's a little bit of triangulation, but we can estimate on these large scales about where the sharks are. The problem with it is that you have up to about 100-kilometer error on those. So it doesn't work when we're talking about a movement from Newport up to Depot Bay. It's not going to work, but it will work if you're talking about going from Newport down to Newport, California. So what we found is when we put these tags on the sharks is that the sharks were actually making these incredible movements. So those times that we didn't detect them along the coast, they weren't just outside the range of our receivers. They were actually moving out to the middle of the Pacific. Some were going as far as Hawaii. Other ones were going to the spot halfway between Hawaii and Baja that we've called the White Shark Cafe. And so again, they're here in the fall and early winter, and then they're moving offshore, and then they're coming back. And so it was these electronic tags that allowed us to really start to understand the movements of these animals. So the next question naturally was, well, why the heck are these animals moving offshore? They're basically in this California current, which is just full of food and things to eat. There's marine mammals, there's tons of fish and other things that they could potentially be eating. But they're leaving basically this all-you-can-eat buffet and going out to the middle of nowhere. So I liken it to being in a buffet in Vegas, and deciding that you're going to leave that all-you-can-eat steak dinner and go out to the middle of the desert for a couple weeks. And so we're trying to figure out, and the only way that we could come up with that sharks would be doing that, why they would be doing it, is that there's either some better food resource that's offshore that we don't know about, or there's a potential to mate. And so that's why we called it the White Shark Cafe. It was a place that you could either go get a bite to eat or go to meet somebody special. And so our next steps were to try to understand why these animals were going out there. How do we figure out, these animals are thousands of miles away, how do we figure out what they're doing? So we wanted to understand a little bit better about what they're actually doing when they're on the coast. And so one technique that we use is another electronic tag, and this is called a biologging tag. And this is a tag that basically can record the movements in 3D of these animals at a really high frequency. So you all have your smartphone, and when you move it around, your phone knows which direction is up. And that's because you have these sensors, gyroscopes, accelerometers, that are telling which direction is down and which direction you're rotating your phone. So we basically co-opted those same sensors and put those into a tag so that we could see how the shark was moving its body throughout the water at an incredibly high sampling rate. So at about 100 samples per second, I can look at how the animal is moving through the water. And this is just a quick video of attaching these tags. These are non-invasive. The shark comes up to the boat, you clamp it on, and then the shark continues on its way. So that tag will stay on for anywhere from a few hours to a few weeks and tell us exactly what those animals are doing. The other cool part about that, it's got a camera. So these cameras not only allow us to, to see sort of movement-wise what the animal's doing, but we see how it interacts with its environment, how it interacts with other species. And this is just one of these really cool sort of findings that let me turn this sound off. These findings that the sharks are swimming through kelps. You'll see some seals at the bottom of the picture here. We always had this idea that kelp was a barrier to sharks, that white sharks wouldn't come into kelp. They didn't want to be bothered by it. But it turns out that, at least in South Africa, that these sharks are actually hunting. There's a different hunting strategy that's happening. So for years, we thought sharks leapt out of the water to eat stuff on the surface, and that's how they predated their food. They were these ambush predators. But it turns out that they also stalk their prey, and they do it in the kelp. They'll basically corral the seals in the kelp, and then the seals go to the surface, and when they're not paying attention, that's when the sharks pursue them. So very different types of things that we can see when we're on board with the animal than we can just from the surface. And it's kind of cool. So if we take the data from those tags, we can recreate the movements of the animals and really find scale under the water. And so the black line there in the background there is just the track of the shark through 5 minutes. The green is places where it was inside the kelp. The blue is when it's outside the kelp. And then the red stars or bursts show where the shark interacted with seals. So you can see that the shark is the only time that this shark is, and if you extrapolate, if you look at the whole set, which is a couple hours long, the only time that the animal actually interacts with seals, the only time that it's actively pursuing prey is inside the kelp. So very different behavior than we've ever seen. One thing I should note is that these are from South Africa. We're trying to find these data, or trying to find evidence of this in California. As many of you probably know, we've had a really big loss of kelp along our coasts. And so basically that has coincided with the time that we've had these tags available. So we haven't been able to find this same behavior in white sharks here, but I wouldn't be surprised if we see the same type of kelp foraging, or at least hiding in the kelp for white sharks in California as well. One thing I do like to also share with folks is that I know it makes all of us a little bit nervous when we thought that, well, kelp is a good refuge from sharks. So if I'm scuba diving, or if I'm surfing or swimming and I want to sort of feel more comfortable, refuge in the kelp. And now I've just sort of ruined that for you, letting you all know that they actually do hunt in the kelp. I wanted to provide a couple examples of why I get in the water very confidently to go surfing, and I don't think about sharks and worry about sharks, because it turns out that there are a lot of us in the water, and there are very few interactions. And these animals are so incredibly discerning. And this is one of those moments that really showed it to me that these are really discerning animals. So this is the camera on the back of a shark. Again, you'll see its head in the bottom of the screen, and how fast it moves back and forth gives you an idea of how fast it's going. So it's going maybe a mile or mile and a half hour. Right now, it cruises up, picks up speed about 25 miles per hour, heads to the surface, big, insane bursts, going up, sees a target on the surface, and at the last moment bails. So this shark has just sprinted. It's basically gone from about a mile or two an hour to about 25 miles an hour in just a few seconds. So it's about 3 times, its acceleration is about 3 times greater than Usain Bolt's acceleration off the line. And so it's just exerted all of this incredible energy up to some type of prey, but at that last moment it bailed. And what we sort of racked our brains about this for a long time, trying to understand what that was and why it bailed. But then we went back and looked at the video really hard. And even though that thing looks exactly like a seal, this is my son. He likes to come watch sharks as well. Hi, bud. Even though it looks exactly like a seal, it turns out that it's a cormorant. And this is Huckleberry, budding shark biologist. It's actually a cormorant. So even though that shark exerted all of that energy and was looking at this thing at the surface that looked like its prey, it got to that last moment and then turned away. It knew what its search image was for its prey and decided that, you know what, that's not what I'm going for. I'm going to bail. So for those of us that are paddling around in the water, this makes me feel better because I know that those sharks could potentially eat me. I know that they are not going to. Or less likely going to, because how discerning they are. This is another video that I like to show. This is a decoy cam, and it's basically looking off the back of the decoy. And again, we've had a shark that we call Mayhem that's been circling around this decoy. And I'll just let you watch this closely for a few seconds. So basically what you see is the shark comes up. It's investigating it, and sharks don't have, obviously they don't have fingers like we do to investigate something. So what they use is they're using their mouth, and that often can be traumatic, right? So if they're using their mouth to investigate a person, that single bite can be quite traumatic. But what's really cool about this is if we watch this again, but we watch it in slow motion, you'll see that the shark comes up and it's going to bite, it's going to lower its jaw and bite on. But if you look at the teeth, those teeth are actually retracting back into its gums, and it's using its gums to test what that is. So it smells like it's bait, it looks like what it's supposed to be going for, but the shark, even though it's exerting all this energy to come up and bite this thing, is still investigating. It pulls its teeth back to use its gums to investigate what it is. So these are just some of the examples that really show me that these predators are incredibly adept at what they do, and they are discerning. They're not just randomly biting things, anything that's up at the surface. So it makes me feel more comfortable about being in the water. So if we look at the data basically from all these videos, about 450 hours of videos from Cape Cod, from South Africa, from California, in all of these interactions, we saw one single natural predation event out of all those 450 hours. So the idea that these are sort of mindless killers going around eating everything and biting everything is not necessarily true. And I'll show you a quick video of what that predation looks like. So again, the shark's head on the bottom. And you'll see a hagfish swim across it and it ate a hagfish. And if you're not familiar with a hagfish, they're also known as a slime eel, possibly the lowest caloric value thing in the ocean and probably the grossest thing that you can eat. They have this 2-part slime that when they get stressed, they release it. And it's like a sticky, oozy jello. And so that's the only thing that we saw sharks eat in that entire time that we were studying those animals with cameras. So we thought maybe there's something about these cameras that are doing something to affect the way that sharks hunt. So we decided a different strategy, and we used what we call a stomach tag. And we would wrap this in some blubber, what we call the blubber burrito, and then feed it to the animal. And the way that this works is that, remember I talked about sharks being these regional endotherms. So they're heating their stomach. The same way that you and I have a warm stomach on Thanksgiving, we go and have a bite to eat, and you start to get a little bit warm, you start to sweat a little bit. Sharks do the same thing. So when they eat something, they're basically the process of digestion warms their body up. So when a shark goes to eat something, it's going to ingest a bunch of cold water. So its stomach temperature is going to drop. If it's unsuccessful, the stomach temperature is just going to go back to its normal resting temperature at about 23 or 24 degrees Celsius. If it's successful, the same way that our stomachs would get warm if we ate, their stomachs are going to get warm. And so you're going to see this spike in temperature if it has a successful event. And that's basically what this looks like. So if you look at the left-hand side of this at time 0, that's when we fed the shark the tag, and you can see the temperature drops, and the temperature's in red. So the temperature drops because that's the cold water coming in, and then temperature goes up to about 26 where it's processing that blubber, and then it drops back off to about resting, which is 23, 24. And then on day 5, it has another event where it ingests water, and then the temperature again goes up to 25, 26, showing us that it was a successful event. So by putting these tags in 8 or 9 animals for over 1,000 hours, again, we saw evidence of one single feeding event. So these animals are not, again, these mindless predators that are going around eating everything. They're actually incredibly discerning in what they eat. So we know that at the coast, they're not eating very often. So does that mean that they're going offshore to eat something more? What does this mean about the offshore environment? So we started to look at isotopes. And basically, you are what you eat. And so you show a signature of the food that you've been eating. And different food in different locations has different signatures. So isotopes are basically the ratios of different elements or different versions of elements in a tissue. So an animal that's a primary producer that's out in Hawaii is going to have a different isotopic signature than a primary producer like algae, kelp, or something on the California coast. And so by looking at the signature of the sharks, we can tell where they've been eating. So you can imagine if you're a shark that lived in California, your isotopic signature is green. If you're a shark that feeds out in Hawaii, your isotopic signature is blue. But if you feed in both those places, you're going to have a mix of that signature. So you're going to be bluish green. So you're a mix of both of those locations. And if we made a map of, so there's carbon isotopes on the bottom on the x-axis, and then nitrogen on the left side on the y-axis. So basically, this is just showing that the prey in different locations have a different signature. So if you are California prey, looks like that top right corner, pelagic prey or cafe or Hawaii prey are down into the left. And so if you're a shark that's eating a little bit of everything, you'd be right in the middle. But what we find is that the sharks actually, the signature from the sharks themselves shows that the sharks are eating more in California than they are in offshore water. So the idea that these sharks are finding some great forage offshore doesn't hold up when we look at the isotopes. So those few foraging events that we see on the coast are actually represent a good portion of the annual foraging that these animals are doing. We also can tell that because if we look at these animals when they show up and when they leave, so this is the same animal about 3 months apart. The left is when the shark arrived, and right is right before it departed. And you sort of compare the girth of the body to the dorsal fin, you can see that animal has grown significantly in terms of its girth, its body condition over those 3 months. So while they're at the coast, they really are bulking up. And this just shows that all of these animals that we've looked at over periods of time have all bulked up while at the coast. So the question is, well, what are they doing when they're offshore? It seems like the foraging is happening onshore, something else is happening offshore. And if we look at the records from these satellite tags, remember I talked about it gave us information about the depth where the sharks are in the water column. If we look at those depth changes, that when the sharks are at the cafe, so basically this time from, if you can see my cursor, from sort of April through July is the time that they're off in the cafe, their vertical velocity, so how fast they're going up or down, how fast they're changing depth basically, increases precipitously during that time. So when they're in the middle of that cafe, these sharks are swimming up and swimming down and swimming up and swimming down, a very unique behavior that's only happening in the cafe. And I should mention that this is only happening in males. So up to 150 times a day, these animals are swimming down to 300 meters and up to 300 meters. Basically, they're sprinting up and down all day, and it's only the males. And what we think that this is actually a way for males to find females. And we know that sharks release pheromones when in other species of sharks. We don't know this about white sharks, but we know other species of sharks release pheromones when they are when they're sexually receptive. If white shark females did that, water is not, it's not uniform. Water is basically stratified, whether it's temperature or salinity or something else. The ocean is like layers of a pancake. And so if you're a female that releases a pheromone into the water and you're a male trying to find that pheromone, it doesn't make sense to be cruising at the surface, because you're never going to smell something that's 500 meters down, because it's never going to mix up to where you are. So the only way for you to interact with that pheromone is to cut through that layer of the water, basically those layers of pancakes, to find that pheromone. So we actually think that this is a signature that may be the males trying to find a female, a receptive female, in the middle of the cafe. So just to sort of recap this, we think they're at the coast to feed, they head off to the offshore area to mate. So that talks about a little bit about the movements and some of the ideas of what these animals are doing annually. I wanted to talk really quickly about these really cool intra-guild interactions. And so basically, a guild is a group of animals that fill a similar role. And so in this sense, we're thinking about killer whales and white sharks. And this figure shows the distribution of elephant seals, which are in blue, white sharks, which are in green, and then killer whales, which are in gray. And if you look on the left side, that shows the sort of when the peak residency time of those animals happen. So if you look at the right side of this, so September, October, November, you see that there is, in all three of these species are peaking at that same time. So you've got prey and two competing predators that are at that basically at the coast at the same time. And what we know about killer whales is that there's three different ecotypes. And so you have these offshore killer whales. Well, let me start the other ones. We have these resident killer whales, are your fish-eating killer whales, and they have specific dentition. They're the ones in the Puget Sound. They're the ones that are eating salmon. You have transients, which are your marine mammal eaters. These are the killer whales that are going out to feed on seals and sea lions, or gray whales and humpbacks and things. And then you have another ecotype, which is called offshores. And these are really cool because they are focused primarily on sharks. And so they're shark eaters. And so if you look at the dentition on the top of this figure, you see that the offshores, which are all the way in the left column, those offshores, their teeth are all the way worn down. So basically the hard, rough denticles or sort of like modified scales on the shark have basically ground the teeth of those whales down. So stepping back, so if we looked at the acoustic data over a year, so before I showed them, I showed the colorful plot that had the acoustic data that showed sort of the seasonal presence. So if we took just the season that the sharks are there and we split it by location, so red here, or reddish orange, is the Farallon Islands. Blue is Anio Nuevo, and then green is Tomales Bay. And those, you can see a map of those locations on the right. So basically that's what a normal year looks like of residency of these animals at those different locations. But in 2009, orcas came through and they were transients, but in California, transients also eat sharks. So transient orcas came through and basically caused this huge decline, this basically total emigration of white sharks from the Farallon Islands. So they showed up at Farallon Islands on the first couple of days of November for a couple hours, and 18 white sharks just up and left, totally left for the whole rest of the year. And this is what the record looks like for those individual sharks. So this is time zero is on the bottom axis there is when the orcas showed up, and then each line on the left side is represents an individual shark. And so basically you can see that for the 20 days leading up to that moment zero, when the white shark, or sorry, when the killer whale came through, that the sharks were there. They were there very consistently. And then that exact moment that those killer whales came through, all the sharks left. And some of them went to other locations, but none of them came back for more than just a few minutes over the rest of the season. And we know that they all survived. None of those animals were actually killed, but somehow they were basically pushed out by just the idea of having orcas there. So that's sort of sums up my the bit about white sharks. I wanted to touch very briefly. I know it's sort of getting late for everybody, but I wanted to touch very briefly on some of the other projects that we have going on, or that my group has going on here, because white sharks aren't the only sharks that are off of our coast. There's a number of other species that are really cool and really important. And so, well, I guess I have to go through this one part real quick. Sorry about white sharks. I forgot about this figure. This is just shows some of the movements of the sharks up into our region. And so these are, the left is satellite tags, and it just shows that the sharks in Central California are making their way up here. And we know that that is changing even more so now with climate, with the warming water. And you'll recognize this young man from that picture. This is also off Beverly Beach this I guess early winter, and this was a sperm whale. I'll turn this volume off, sorry. A sperm whale that washed up with about 45 individual bites on it, and some of them up to about 2 feet long, or 2 feet wide. So it's just a really good sign that these sharks are up here. I'm sure all of you have heard stories, or some of you may have seen them already. But I think with climate change, with the warming water, we can expect to start to see more of them. And that's what my group is out here to do, is start to understand a little bit more about how they're using habitat and their timing and things up here, and if they're part of that same group that's down in Central and Southern California. So these, again, are not the only shark species. Salmon sharks, which are a relative of the white sharks, which is in the top right there, also move down. So their satellite tracks are on that bottom right figure. And then the figures on the left just show some of the seasonal, it's a kernel density map. So places where you see hotter colors, there's more animals there. And so you can see sort of that these salmon sharks are coming down and sort of hanging out off of Newport and our coast in that August, sort of August to November period of time as well. So this is another really important species for salmon, for hake, for other important coastal resources that we have here. And then one of the biggest apex predators that we have around is the broad-nosed seven-gill. And we're putting some of the biologging tags and acoustic tags and satellite tags on these animals, trying to understand what role they play in our bays and coastal ecosystems throughout basically the whole Northern California current system. And then the last one of these Pacific sleeper sharks. These are big, slow, deep water predators. And again, putting biologging and other tags on these animals, trying to understand what they're doing and what their roles are in our coastal systems. So this is just a quick recap. These sharks are really important to our ecosystems, that their numbers are, attacks are rising, but the probabilities are going down just because there's so many of us in the water. That they're seasonally here, but they are these really discerning predators. And so it doesn't need to keep us from getting in the water to enjoy it. And throughout Oregon, there's other species that are really important as well to our coastal ecosystems and the health of our resources. And that's what my group is going to be studying over the next, hopefully for the next 30 years. And with that, I just wanted to put up, this is my website. If you go to search the Big Fish Lab or me, Taylor Chapple, you can find more about the work that I do, my lab does. You can find us on Instagram about the different research we do. And also, if anyone sees a shark, we have the shark sighting page, shark reporting page. So if you ever see a shark, someone tells you about it, or you get any information, please upload that. That comes to me, and then it's giving me a better sense of the timing of where these animals are and where we can find them. And I'm hoping to use that as a resource so that as a community, we can start to understand more about these animals. So with that, I'll say thank you to everybody. Thanks for being here. I know Zoom is not the world's best way to interact with everybody, but I appreciate you all coming to this. And with that, I'm going to stop sharing screen, and then I'm happy to answer some of the questions. So if anyone has questions, go ahead and put them in the Q&A chat, and I'll read through them and answer them as I can. Hold on one sec, buddy. All right.
Hey, Taylor,
so,
this is Kevin. Just
Yep.
letting you know, we got a couple questions in the Q&A, but then we also had a few come in via the normal chat screen. So they're going to be in 2 separate places.
Okay. All right. So let's see. Bill says estimates have put the numbers of sharks being killed worldwide every year about 100 million. So how accurate is that? And given that California Central Coast white sharks populations, 2 or 3 large populations. Okay. So the question is about how we relate that couple of hundred animals to the estimates, the global estimates of about 100 million sharks being killed annually. So just to clarify, the 100 million number is actually probably an underestimate of the global shark catch. It's probably much higher than that. And those numbers are for a lot of basically the whole assemblage of species, and that will include rays as well, likely. So, a lot of these species are much more abundant in terms of, hundreds of thousands or millions of these different species in their respective populations. It just happens to be white sharks, which are these, there's really large apex predators. Their numbers are naturally lower than those. It's the same way that you would expect to see a lot more, let's think, I'm trying to think of some like a mesopredator. So like you're going to see a lot more lingcod or something than you're going to see white sharks, because lingcod are, granted they're different, elasmobranchs and teleost, but the idea that they're sort of a middle predator as opposed to the highest apex predator. So that's why there's that. So I think, yes, that number is probably an underestimate, but that's why it's so much, it seems so large compared to, being a couple hundred white sharks in these different populations. Okay, so Carrie has a really interesting question about squalene, which is being harvested for making vaccines. And that's one of the ones that was talked about recently for a COVID vaccine. Do I have any insight into this, and do I think it will affect shark numbers? So there is, my understanding is that there are ways to synthesize squalene. Some of the concern is that we are basically going to try to come up with a way to make a vaccine, and once we figure that out, we're not going to try to vary it. We're just going to try to mass produce it. And so that's a concern that we may not actually synthesize the squalene and use it from sharks instead. I think that, I mean, as Bill's comment said, we're killing 100 million sharks a year. And I think that they're talking about maybe 500,000 sharks would be killed. Would be killed for these for this squalene. Hold on one second. This is the joys of having kids at home. So I think that I mean, in an ideal world, we would take some of the sharks that are harvested legally and collect the squalene from these animals. And whether that's going to happen or not, or we're going to start a new culling efforts, that's the part that worries me. But right now, we harvest more than enough of these sharks to be able to get enough squalene to satisfy the vaccine needs that we have. Okay, so Bill has one more question about what's percent of the total shark populations are white sharks, and what's the most prominent shark species? White sharks are going to be a fraction. There's about 400 different species of sharks. White sharks are going to be a fraction of the percents of overall shark numbers. And I don't know about which ones would be the most abundant. Things like blue sharks have a much faster and higher reproduction rate than other species, and they do really well. They're sort of like a scavenger. I'm sure if anybody fishes, you've seen blue sharks at some points, and it may be that they're some of the more abundant species, but I don't know offhand which species is technically probably the largest abundance. let's see. And then someone asks, can you speak a bit more about how the sharks are able to retract their teeth into their gums? Is that something that most sharks can do or just certain species? So let's see. I haven't really thought about other species. I am gonna have to say that I'm not certain about that. I think that they all have an ability to retract to some degree, and I don't know. That's a really interesting question, because I'm not quite sure about all the other species. I don't know much about the morphology of different species of their mouths. But I'm going to find that out. I'll be really interested to find that out. So if you want to find that out, I will find that out and I'll put it up on my Instagram. And I'll find somebody that knows and answer that. And so I'm not sure who asked that question, but that's a great question. So I'll have to get back to you on that. Okay, and I'm going to jump into some of the chat questions. So is there any possible migration correlation between tuna migration and white shark migration? And I'm not sure if you're talking about that cafe or what, but so one thing is that we do know that in the offshore water, so last year, no, 2018, I was out in the cafe on a research vessel. And at the same time, we were seeing big eye tuna boats, and we found out that they do interact with big eye tuna out there. So there is some, I guess, correlation between the migrations of those species. The interesting thing, though, is when we go back to those isotopic data, that it doesn't indicate that the sharks are eating a whole lot while they're out there. So while they're there at the same time, and maybe they are picking off a few here and there, it doesn't seem to be what's driving them to go out to that cafe. So it says today there's a sighting off Indian. So Indian Beach. So it is that time of year for the sharks to start showing up. So I wouldn't be surprised. So down in California, where I do most of the field work, the sharks have started showing up. I'm actually going to be heading down there in the next few days to start field work down there. So this is a time that we may start to see sharks starting to hit the coast. I'm expecting that peaks here will be October, November in terms of timing. But again, that's what we'll find out. My goal is to basically to wire the whole coast with an acoustic array so that we can see when these animals are moving in and moving out into our region. Okay, so Charlie says he thinks the spiny dogfish would be the most abundant. That's, yeah, one of those sort of small coastal sharks may be one of the most abundant. Yeah, again, I'm not quite sure, but that's probably a pretty good bet. Let's see. Read another one. Do we have any good idea of why the interaction probability has dropped? So the probability of attacks, I'm assuming what that's talking about. I think it's just the sheer number of us getting in the water, and that sharks aren't necessarily keen in. There's a lot of prey potential. Marine Mammal Protection Act went in the early 1970s, and we've seen exponential growth of marine mammal populations. So they're really preferred prey. So I think that together with the just sheer number of people using the water, and probably more awareness of people of figuring out where places to avoid or times to avoid places, I think has probably led to some of that decline. Let's see. There's a longer one here. It's going to take me a second to read. So this is a question about if there's any, so some questions about whether there's efforts to tag up here. So that's why I'm here. So I came about just over a year ago to OSU. I've been down at Stanford the past about 15. So I just came here, and that's part of my goal is to get my project and my lab up and running here and start studying these movements. So tagging these animals. So again, if anyone hears or sees anything about sharks, to put up on that sighting, the sighting page on my website, because that'd be a great resource for me to figure out where people are sighting them so I can find them. Finding white sharks, if you don't know where to look, is sort of like a needle in a haystack. So any information or thoughts I get from any would be much appreciated. You can also get my email address from the website. This JB also mentions that there's a footage of a white shark feeding inside the Columbia River last year. I have not seen that. I would love to see it. So if anyone is familiar with that, or JB, if you know a link to that, I would love to see it and read more about that. So so I think that sort of looks like the list of questions. Anybody has anything else, let me know. Otherwise, you probably all need to go refresh your beers, and I'm going to have a sip of mine right now.
Thank you, Taylor. That was fascinating. I want to thank the rest of the Chapple men for entertaining us.
Yes, they're now building airplanes loudly next to me. So they're my wife is also faculty here, and she's giving a bird talk right now. So the boys are sort of like freewheeling around, to take part in both of our talks.
Free ranging.
Yes.
Thank you very much. We really appreciate it. And I want to thank everybody for attending tonight and remind you that we're still accepting donations for the Echo Mountain Fire Relief Fund. You can go to the Eventbrite page and donate until about 9 o'clock tonight, I think. So I want to encourage everybody to help the people that are affected by the local fires in your area. And thanks again, Taylor. And we'll
thanks a lot for having me. Hope to see you all in the lineup someday when I actually am not just watching kids and can actually get in the water and surf again.
Deal. Good night.
Sounds great. Have a good night, everybody.
All right, everyone. Thank you for joining us tonight. If you have any questions, feel free to go on to the Surfrider website, shoot us an email, and we'll try to forward those on to Taylor and see if we can get a response. Thank you for joining us, and you all have a great evening. Bye.